welcome back to my next video, guys. In this video we are going to learn about logic gates, which are a part of Boolean algebra. So we will start with the first logical operator, which is logical NOT. This operator gives the complement of the binary valued quantities given by the user. It converts zeros into ones and ones into zeros. It is represented as apostrophe or a hyphen. To understand this more clearly, we would represent this by using a truth table, where we will take the value and the output. As we can see that the output get reversed as that of the original value. Let's draw a Venn diagram to understand this more carefully. Here the circled one is the original number, whereas A0 represents the logical NOT operator. Let's move on to our second logical operator, which is logical OR. This operator results in logical addition of two or more binary valued quantities. It is denoted by a plus sign. Also, it returns 0 when all the operands are 0, otherwise it returns 1. It is also denoted by a plus sign. To understand this more carefully, we would represent this logical gate with the help of a truth table, where we will draw three columns, namely as A, B and output, where A, B 0 0 0, 0 1 1, 1 0 1 and 1 1 1. Let's draw the Venn diagram of this particular logic gate. Where A, B are the parts of this diagram, and where the highlighted portion represents this logic gate. Let's move to our third and the last type of the basic logic gate, which is logical AND. The AND operator results in logical product of two or more binary valued quantities. It is denoted by a dot sign. Generally, in this truth table, it returns 1 when all the input values are 1, otherwise it returns 0. It is generally represented by a dot sign. To understand this more carefully, we would represent this by using a truth table, where we would draw three columns, namely as A, B and output, where A B value will be 1 0 0 0 1 0 1 0 1 0 0 and 1 1 1. Let's draw the Venn diagram of this particular logic gate, where A and B are two sets of this diagram, and the highlighted portion represents this particular logic gate. Now let's move to our next topic, which is known as the compound Boolean expression or complex Boolean expression. This is nothing but a combination of the basic logical operators, namely AND, OR, and NOT. A complex Boolean expression formed by using two or more operators is known as compound Boolean expression. I would like to explain these compound Boolean expressions with some examples. For example, the first one will be logical NOT, which is formed of OR and NOT operators. The second one will be logical NAND, which is formed of NOT and AND gate. The third one will be logical XOR operator. It is also known as exclusive XOR or exclusive XOR. It is formed by AND, OR, and NOT operators. And lastly, the last one will be logical XNOR, which is formed by the combination of XOR and NOT operators. Let's move to our first compound Boolean expression, which is logical NOT. It is formed by a combination of OR and NOT operators. Generally, this particular logic gate is used to reverse the function of OR gate. It will be represented by A plus B complement. To understand this more carefully, we will draw a truth table and a Venn diagram. In a truth table, we will draw similarly three columns, namely as AB output, you can see the result of this, the following outputs, and the Venn diagrams as A and B are particular sets of the following gate, where the highlighted portion represents the positive part of this particular gate. Let's move on to our next logical operator, known as logical NAND. Logical NAND expression is formed by the combination of AND and NOT logic gates. Generally, this gate is used to reverse the function of logical NAND gate. It is usually represented by A dot B whole complement. To understand this more carefully, we will draw a truth table. By drawing 3 columns, we would name the 3 as A, B and output, where we will label the following as 001, 011, 101 and 110. The Venn diagram of this particular NAND logic gate will be A and B, showing the 2 sets of this particular gate, where the highlighted portion represents the positive side or the on side of this particular gate. Now let's move on to our next logical gate, that is the logical XOR gate. This operation is short form of exclusive OR or XOR. The logical XOR expression is formed by using a combination of all 3 fundamental operators AND, OR and NOT. This particular gate will be represented by A complement dot B plus A dot B complement. To understand this gate more carefully, we will draw by using a truth table. We will draw 3 columns, namely A, B and output. The output, remember, the output will be represented by the symbol as shown above. We would label A and B as 11, 000, 011, 101 and 110. In this Venn diagram, we will draw A and B as the 2 representatives of this equation and mark the positive side of the cell as follows. Now we will move to our final part of the compound Boolean expression, which is the logical XNOR, which is made up of logical XOR and logical NOT operator. Basically, it is used to reverse the operation of XOR gate. It is usually represented by the equation A complement dot B plus A dot B complement whole complement. To understand this particular gate more deeply, we will draw a truth table along with a Venn diagram. In the truth table, we will follow the same pattern of using 3 columns, where we will mark the following as A, B and output, and mark the following as 001, 100, 100 and 111, and represent the Venn diagram by taking 2 sets A and B and marking the positive side of this particular gate. And here comes the end of our video. If you haven't subscribed our channel, please make an effort to do it, and if you like this video, please do share with others. To help others benefit it, please make an effort to do it. And lastly, thanks for watching.